So now we're going to look at perfect square trinomials. The number one problem I tend to have with students is learning to recognize them. So we are going to talk about that before we get into it. First, what is a perfect square trinomial? If you turn these around backwards, they look like what you did when you were learning to multiply binomials. So when you multiplied a binomial by itself, therefore squaring it, it always came to be the same thing, okay? Or it fit this pattern. It was an a squared plus 2ab plus b squared. If you multiply a plus b times a plus b, this is what you get. If you multiply a minus b times a minus b, this is what you get. It always worked out the same, and therefore we call these perfect squares because they result from squaring a binomial. Now again, the problem most students have is in recognizing them. And again, if you learn those square numbers and learn to recognize them, you'll be able to see real quickly, oh, that front guy's a square, that back guy's a square. Well, take those two square roots, multiply them together. If the middle term is double that, you have a perfect square trinomial. No need to do tic-tac-toe. No need for any kind of thinking. It's actually a very simple problem. For example, when I see this problem, the first thing I see is that 16 is a square number and 49 is a square number. So I'm thinking for x, no, I don't write it. I'm thinking 7. I see those squares right off the bat. Now multiply those together, I get 28x. If I double 28, I get 56. Therefore, this is a perfect square trinomial. So all I have to write, all I have to do to factor it is to write the square root of that front number, the square root of the back number, and steal that sign in front of the linear term and write it as a square. And it's correct every time. Now let's do that again, but with more variables. I have 16 again. I know that's a square number. I have 25. I know that's a square number. Multiply these two guys together, I get 20pq. If this middle term is twice that, which it is, I have a perfect square trinomial. So all I have to do is write that 4p, the 5q, pay attention to my linear term here, write that sign, and a square. Very quick, very easy. That's what the formulas are for. They're not intended to make your life difficult. They're actually intended to make you have a few shortcuts. One more example before we go. I see big numbers. I really don't want to do tic-tac-toe because I don't know what 169 times 16 is. But I recognize 169 is one of those square numbers Miss Harold told me to recognize. So 13x is what got squared on the front. Miss Harold, that's not a square. No, it's not. But it is an even number, and any even number can be a square. So that's going to be 4y squared that got squared, because when you raise a power to a power, you multiply the powers. Now, 13 times 4, okay, I do believe that's 52, if I can write it. Maybe I can, maybe I can't. And that's xy squared. Well, notice I got the xy squared part right. And if I double 52, I get 104. So that was a perfect square. So it's 13x. Now this time my linear term had a plus sign, so I'm going to put a plus there. 4y squared squared. Much faster, much easier than factoring any other way.